Hey guys, what's up? We're up to grade 3, part 4, show you work, hardest math problems. All right, I'm going to jump right into this because I have limited time. I have a session right after this, so I'm going to just start up and we can go for it. Okay, give me 1 second to reset this. We're in grade 3. We're going to do all the different grades, and we're just going to be going through what I'm terming the hardest math problems, which are being sourced from the New York State exams that most kids got wrong. Actually, a lot of kids got this one right. I just want to kind of go over it just to be sure that you guys are kind of grokking that there's 2 things here. There's an A part here, which is how can Wyatt find the missing factor? Okay, and then there's kind of a B part here, which is be sure to include the value. Okay, so some kids might explain this out. You all know that the answer is 3 here, right? 8 times 3 is 24. There's a fact family, right? Depending on how you learned it, there's 24, and there's 3 times 8, right? And we can multiply it out. It's also the same as 8 times 3, so we can do 3 times 8 equals 24. 8 times 3 equals 24. And part of that same fact family is 24 divided by 8 equals 3. And 24 divided by 3 equals 8. So these is the FFs, the fact families, okay? So given that we have those 4 choices, Wyatt wants to solve the equation below to find the missing factor. The missing factor is 3. So you just can't explain that multiplication is the reverse of division. That's part of your explanation. And by the way, if you notice, I'm going to underline this here. 1 second. Normally, it says explain why or why not. So this is different coded language, if you will, asking you to do the same thing. But it's the same explaining by mentioning the 3. So you just can't say that it involves multiplication and division. If you leave out 3, you're not going to get all the points here. So I think this is probably the problem a lot of kids write into on this question. All right, so that's kind of what this is about. Getting back deeper, though, into the math concepts. Again, this is about equal parts, right? It's about multiplication table. It's about fact families. Also, they mentioned there is a term here, so there's terminology. Okay, missing factor. Okay, equation. So you have to be understanding division, right? You have to be understanding a value of the missing factor again here, right? And you should know your terms of multiplicand, times a multiplier, is equal to a product. There is some controversy of what goes where, because normally we're at 5 multiplied 4 times, right? Because we're going to basically have 5 plus 5 plus 5 plus 5, okay? And that would equal 20 in both cases, obviously, okay? But when we say something like, what is a half of 20 or something like that, this means a half times 20. And the multiplier is really the half. It's not the 20. Okay? And it depends how we look at this. This is like when you're sending a file to a computer. Are you uploading or downloading it? Depends on what side you're at. If you're the uploader, then it's downloading to the other side and vice versa. Okay? So this kind of has this queasiness factor, but it's more important to know that we're multiplying here, and that's why this question is avoiding terms. The same thing goes with division, with quotients and stuff like that. You should still know what's where, but you know, the concept is what you're being tested on most of the time, and not just terminology-based kind of things. Okay, so the next thing, we notice that there's an illustration here. It appears to be 4 equal parts. Okay, I am not sure. They might be asking us about the area or something. That might give us the dimensions. There is nothing else here. It just looks like a rectangle split into actually each part. It's hard to tell. Those might be squares, but I have a feeling they're not squares. This part here, this, if I call that little part there, the A looks a little bigger than the B to me, but it could be an optical illusion. Actually, let me do this. Nope, they may actually be squares when I put my hand over it. All right, so we don't know, and we're going to go overboard in analytics to find that out. So 2 families buy large sandwiches, and let me get rid of these extra clutter I just put there, because it may not involve the question. 2 families buy large sandwiches of the same size. Family A shares 1 sandwich. So this is family A's sandwich equally among 4 people. So each of these is a quarter. Because the 4 equal part. The whole is the whole thing. Okay? So if we were to ask what is the size, let me get a light color here. 1 second. Let's use orange. What is the size of 2 here? Okay? It's 1/4 out of the whole. Right? Piece 2 is 1/4. If I eat piece 2 and piece 3, I would be eating 2/4 or 1/2 of it. Okay? So again, 2 families share the same size. Cool. Family A shares 1 sandwich equally among 4 people as represented below. So that's what we're literally saying. Family B shares 1 sandwich equally between 2 people. Okay? So there is a second sandwich. Okay, and I'm going to draw it just straight below here. We don't know if it's exactly the same size. And it's between 2 people. So we're going to have 1 and 2. This is in halves then. Okay, so they're probably going to ask us to compare a piece of B to a piece of A, right? And it's equally. We know it's a half. So if we have a whole that's split into 2, then it's a half plus a half is a whole, right? So again, this is about equal parts, about a whole again, the concept of a whole. Will a person from family A get the same amount or a different amount of a sandwich as a person from family B? So this is question number 1. So the answer to there is no. Because a person from, let me just make that, a person from A gets a quarter and a person from B gets a half. Okay? Okay, be sure to include what you know about the fractions. So this is the second part of it. So the first part was right here, and I'm giving the explanation, right? And 1/2 is greater than 1/4. Okay? That's your explanation. That's what they're looking for. Okay, and if you want, you can add how you know that. You can do a cross product. You know that if the numerator is the same and the denominators are different, that the larger denominator is actually the smaller fraction, and so on. So that's what they're looking for here. It's just not yes or no, and it's giving the details of what you know about what you're seeing. Okay? There is a slight gotcha to this problem. It says they buy large sandwiches of the same size. So even though the original box in the B I drew is smaller, the 2 sandwiches are literally exactly the same size. If they were not the same size, we couldn't do a comparison because we don't know. They didn't tell us the relative size comparison to us, so we don't know that. Okay, so this is also about that. We're doing equal parts, and we're comparing stuff. It ends up being fractions, right? Now, what some kids do, and let me change the pen of this just so we can get darker again. Let's go back. Okay, so because there's 6 parts, 1, 2, 3, 4, I'm going to put 5 here in parentheses, and the next part is 6 here. Some kids just assume that each part is 1 out of 6. That's if we were taking them all together. And they would be unequal parts at that point, because part number 5 and 6 are not the same sizes as part 1, 2, 3, 4. So some kids just assume that they all get a 6th. That's true, but that's a different question. Okay? That's a totally different question. So we can't go by a 6th there. Okay? The parts are unequal parts, so we can't go by that. Okay? What some kids seem to do as well is they take the one sandwich, which they showed us was in fourths. Okay? And what they do, let me change the color one more time, is because it says family B got between 2 equal parts, what is they do is they take these 4 parts here, 1, 2, 3, 4, and split each part into another half. And then that student says, well, this is now in equal parts of 8s, which would be true. However, that's not what the question says. So this is no good either. Okay, this is totally a no-go. Totally a no, go. Okay, so be careful. Be super duper. And by the way, I want to do a pointer that the original one here, A, is split into quarters. And just to show another way to show that we can get this 8th, even though it's the wrong answer, because this came up in a few of the other ones where I say it's half of a half or whatever. So if we do a half of a quarter, of means multiplication, so we multiply the numerators, we get 1 times 1 is 1, we multiply the denominators, we get 8. Okay, so even though this is the wrong answer, that's how we can get half of a quarter. We can also do a quarter of a half. If I have a half, if it's a quarter of, then of normally implies multiplication, and I still get an 8th. And that's cool because we know by the commutative property of multiplication that A times B equals B times A. Booyah, look how everything works out. Okay, so this dealt with equal parts. It dealt with reading a word problem and trying to understand it. It dealt with the visual. This isn't too deep in multiplication. I mean, you still need to know about a quarter. It dealt with the sum of a whole. The sum of the parts equals a whole, right? And again, this is about equal parts and the comparison of the 2 fractions, because that eventually became our answer right here. We had to end up comparing a half to a quarter, all right? So that's kind of where we're going here with this, all right? A lot of kids got this question wrong. I think it was less the math than the words, but reading words is actually part of the math. If you're not understanding what you're reading, you're not processing it, always look at the visual. Always take the sentences 1 sentence at a time. And also, again, remember, there was 1 question here and a 2nd question here. These are 2 parts. You can answer it all together, but you have to answer every part at some point somewhere. So if you don't answer them linearly / independently, answer them all together. But you have to give a complete answer that addresses in the full what they're asking. If you still answer both questions but only give partial to both, or one you do full and the other do partial, you're not going to get full credit. You're not going to get full credit, right? It's that simple. Okay, that's 35. And we're going to go about an hour here. Again, if you're catching this on the replay, you can stop it and just proceed from there. All right, so again, I like these bullet things because it kind of lays out for us kind of steps to take often. So Susie made cupcakes with her friend. Oh, yeah, booyah. She started at 2:40 p.m. So that's probably something we need to be being aware of. Start. And if you notice, I'm writing down my givens. The list below, what list? This list here, 1, 2, 3, 4 things, shows the number of minutes it took to complete each step. So that's in minutes, that's in minutes, that's in minutes, that's in minutes. So far, everything is in the same units. Everything's minutes. Okay? What time did Susie finish frosting the cupcakes? Okay? So this is clearly a problem where we have to add things. So there's a couple ways to do this. We can add the 9 minutes for the batter. Okay, so let's do that. That's written sloppily. Let me erase that for 1 second. So we're going to add 0 hours and 9 minutes. So 9 plus 0 is 9. 4 plus 0 is 4. We drop down the colon, and we get 249. Okay, now we're going to add 18 minutes to that. No hours and 18 minutes. 8 times 9 is 17. 7, carry the 1. 4, 5, 6. And we had 2 here. Okay, because we now have 267, we need to borrow 60 minutes and bring it into this here. So this is the same as 3 o'clock and 7 minutes, right? Because 67 is 60 plus the 7. So we normally don't go beyond that here. So now we're going to add the 5. Okay, so we get 312. And finally, we're going to add the 10 minutes at the end. So we get 3:22 p.m. Okay, just to be clear, it's giving us a hint here. We always use that to make sure that it didn't ask us, because there is another way to solve this, which is to just add 9 plus 18 plus 5 plus 10. So if we do that, we get 16, 17, 2, 2. I believe that turns out to be 42 minutes. Let me just double check that. 15, 25, 33, 42. Yep. So you get 42 minutes, and some kids might think this is the answer because they did a lot of work already. But if you come down here, it's not 42 p.m. All right. But anyway, what we had to do then, if you solved it that way, is take the 240 and add the 42 minutes to it. Okay, in which case 0 plus 2 is 2. 4 plus 4 is 8. Drop down the colon, and that's 2. So we have the same kind of dilemma here. We need to subtract out of here 60 minutes. So we're going to get 2, 2, 2, and we're going to take that 60 minutes and add it to here. So this becomes 322 again. So we double checked by doing a different strategy that we still get 322. All right. So a lot of kids got this wrong as well. That's really the 2 ways to do it. Remember, this is a 2-step problem. Okay. You don't just get the 42 here and be done. And it's the same with all of these. If you notice, I keep pointing out like this. There was part 1 here, part 2 here. Okay, same with the question before it. Right? There was part A here, part B here. So there's almost always a multi-step thing going on here, where either you have to do multiple computations and use the previous computation. That's what we did here. In the case of the second way I solved it, we used the 42 here to add back into the 240. All right? So this is about time, right? You're tested on time through all the different grades. And that's pretty much what's going on here. In terms of equal parts and unequal parts, these are all unequal parts because they're different times. Okay. Some of you also like to take this 42 and start adding 10 minutes at a time. So we start at 240 because this is 40 plus 2, and that's obviously 10 plus 10 plus 10 plus 10. So if we add 10, we get 250. So that's one of them. We add 10 again. We get 260, which is the same as 3 o'clock. We add 10 again. We get 310. Let me scroll that up slightly. So we added 10, 20, 30. So we're going to add another 10. We get 320. And we're still left with the 42, this 2 part here. So we're going to add the 2 there, 0, 2, and get, whoops, what just happened there? My screen just scrolled. And get the 322 again. All right, so this last technique seems to be the long way to go around it. But for those who can't really figure out the other ways, it's just, these are about getting it right. It doesn't matter which way you do it. However, I would go with one of the first 2 ways because that's really tapping into your math proficiency, and that's really, really where you should be tending to go with these kind of questions. So again, this question also deals with basic arithmetic, so it's about operations you needed to know to add. Some kids are going to do 240 and subtract 42 minutes off of it. They might get the 42 there, and they're probably going to do that wrong, right? So 242 minus 40, right, is going to give you 138. Right? If we subtracted 40 from it, we get 158. Okay. And we can actually do that. Let's do it longhand. We have 240. This is not the solution to the question. I'm giving extra fodder here for you guys. Okay. We're going to borrow time. Okay. So first of all, we're going to take from here. We're going to get that. So that's our 8. Okay. Okay. This is the 3. So we can't borrow from that. We have to take from here 60 minutes. So we're going to add 60. So we're actually going to get, this is a 9 now. Because we're changing the 30. We're adding 60. We're going to get a 90. Right? We already did the 0, so we don't care about that. So 9 minus 4 is 5. And then we changed the 2. We dropped it down. We get the 1. And then it would be PM. However, this is not the way to solve the question. This is not the question. Another kind of gotcha kids do is, let me change the pen for 1 second. The color of the pen. Let's scroll this down so the question's still showing. It says, what time did Susie finish frosting the cupcakes? Some kids just look this here and they say, well, it took 10 minutes to frost the cupcakes. But remember, the answer is still looking for a PM. You just can't put 0:10 here. First of all, it's the wrong answer, but that's your clue that your units are screwed up. Because 0:10 is only in minutes. It's not a time relative to the start of the day or whatever. All right? So some kids make that mistake as well. What some kids also do is they take the 240 and using that, they subtract 10 minutes. And they get 230. Okay? That's a no-go. Can no do. Right? Read it through. She made cupcakes with her friends. She started at 240. The list below shows the number of minutes it took to complete every step, each one. She did all the steps. She didn't just do the last step. So what time? What time of day? There's a time of day implicit here. Did she finish frosting the cupcakes? It didn't ask how long she took to frost the cupcakes. It already told us that right here. Okay, so be super duper, super duper, super duper careful. So this is another question that's relating to time. And there's a whole bunch of gotchas involved in there. Okay, so that's just reading the problem, taking it a step at a time, going through the logic, and then kicking down to the arithmetic. This arithmetic wasn't too bad. And just remember, if you're borrowing or adding, if you're overflowing 60 minutes, you go from 59, you have to bump up. The next level is the hour. If you're borrowing from the hour, you're borrowing 60 minutes. So you have to go back and forth. That was the two examples that I gave you guys, all right? And this really dealt with time of unequal parts, the unequal parts being right here, okay? So that's the kind of the concepts behind that, all right? And again, a two-step problem. And be careful of the overflow or the underflow based on that 60-minute kind of thing. Okay, so we have what looks like a simple word problem. And usually the tinier ones are kind of harder. What I'm starting to notice, just without even reading, there's a number there, there's a number there, there's a number there. So it's already slightly busy with numbers, even though there's not too many words going on there. All right, so let's kind of see what's going on here. Ashlyn rides her bike 2 miles to school. So her home to school is 2 miles. Okay? Okay? So it says, let me change the color one more time here. She rides her bike 2 miles to school, so she goes this way, right? She gets there, so she went 2 miles, okay? And 2 miles home, so then she goes back again. Each day, okay? So each day she's doing 2 plus 2 equals 4 miles. Right? That's what it says. So we're up here. How many total miles will she ride her bike to school and home? Not just one direction, both directions, in 40 days. Well, it seems to me we're going to multiply this by 40. 4 times 40 equals 160. Okay? So how many total miles? So our answer should be in miles. And that's another way to double check that we're solving the right problem. Some kids do the 2 plus 2 equals 4, and they stop here. That's no good. So the answer is not 4. We have to use that number to do the 4 times the 40 gets 160. Okay, so what we're going to do is peek at the units again to make sure that we seem to be on board. Yep, it's looking for miles. But again, the units alone is not going to help us because, again, the answer is not 4. The answer is 160. There was other ways to do this. You could have taken home to school, which we know is 2 times the 40 days, and we could have gotten 80 there. Okay, then this school to home, which we know is 2 miles again, times the 40 there, is equal to 80, and then the total is going to be 160. So you could have done it that way as well. And if you notice, this is 2 times 40 plus 2 times 40. And in this problem, it's not that big a deal, but this is the distributive property, because this is actually 2 times 40 plus 40. Okay, and that's going to be equal to 2 times 80. And that's equal to 160. Remember, your distributive property is A times B plus C equals A times B plus A times C. And it depends how you parenthesize it. I should have wrote it this way. A times B plus A times C, because we're still at the grade 3 level. Okay? It's also true that the reverse is the same. A times B plus A times C equals A times B plus C. And if we turns out this was our line right here, A was 2, B was 40. A was 2, C was 40. Turns out they're the same number, but there are different things here. So we have A plus B times that, and then we got A times B plus C here, all right? So we can go in this direction or in that direction when we do this this identity property that is wonderful mathematical property. Okay? All right, so that's partially the way to do some of this. The solution was not to take 160 plus 40 and get 164. No go. Don't do that. Okay, don't oversolve the problem. Don't overthink the problem. Okay, some kids will get the 80 here and just stop. Or they'll do what I just said. They'll do the 80 plus the 4. Nope, no good. You're mixing and matching things that are not really connected to each other. What we're also not doing is taking the 40 days, right, and dividing it by 4 and getting 10. Okay, we're not doing that either, right? Think the problem through, right? She's doing 4 miles a day in 40 days, right? And sometimes it's worth just bringing it down to lowest level. If she does it for 1 day, she's gone 4 miles. If she does it for 2 days, hasn't she done 4 plus 4 equals 8? Okay. If she goes for 3 days, isn't she doing the up to what she did there? Or 4 plus 4 plus 4 equals 12. So we can see these numbers are increasing by 4, right? That's our pattern, plus 4. So isn't it the number of days times 4, right? It's 4D. That's our formula. The total equals 4D. 4 times the number of days. So that would give us 4 times 40. And that's how we get the number 160. We're talking about this algebraically, symbolically, conceptually, right? We're solving real problems. We're also trying to address how to problem solve symbolic concepts and things like that as well, right? That's what these sessions are about that I'm doing here for you guys. And that probably covers most of the error kind of things kids will do with this. Yeah, that's probably about the gamut of it. Okay. So we'll do the next question. So the concepts here was equal parts. We can either do 40 times 2 plus 40 times 2. They're equal parts there. We can do the 4 times the 140 is equal parts. It also dealt with the multiplication table again. Basic operations, addition, and multiplication, right? We could have also counted up, which is painful. We could have done, if we knew 2 plus 2 is 4, we could have done the 4, 8, 16, yada, yada, 40 times to finally reach the 156, 160. That's a painful way to approach this, so I wouldn't necessarily suggest that. And it's going to be error prone too. By the time you got to the 160, you probably would have made a mistake, and you're probably going to have like 162 or 159 or some nonsense like that. All right, that's why I'm keep honing on the multiplication table, and you want to shoot at knowing that and doing this in the easiest way possible, so it's not error prone, and that you're training yourself to think mathematically and training yourself to understand what is being asked of you. Okay, guys? And by the way, this only has one question, which is how many did you write in 40 days? However, there were 2 parts to it. The first part was combining the 2 plus 2, and you can either combine it by saying the 4 or combining it by doing the 40 times 2 plus the 40 times 2. There's 2 steps no matter how you slice this. So there's another example where it's multiple steps. Sometimes there's only 1 step, and sometimes there's only 1 question they're asking you. Okay? Sometimes there's more than 2 steps. Sometimes there's 2, 3, 4, 5 steps. Okay? So you can't just go by that most of these are 2. Most of these are 2 because these are grade 3 questions. All right? Okay, so 2 figures are shown below. Okay, so we're going to look at them. We have figure A and figure B. We must look at the key. Okay, that says 1 square here is 1 square foot. Okay, and they're probably going to have us compare areas. So let's go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So this whole thing is a 6 times 7. this is 42 square feet. Okay, and we can do kind of the same thing. That is 1, 2, 3, 4, 5, 6. We can start out by counting them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So this should be 30 square feet. We don't know what the question is yet. So I'm over solving this, especially if that wasn't the question. I spent a lot of time counting those. But most likely it is. So there's really nothing else going on in this figure. And there's other ways to get the area of the right side one. So we're just going to leave with that for now because that may not be the question. So it says, what is the difference? That means subtract. In square feet. So this is square feet. This was square feet. This is square feet. Everything, there's no unit conversion between the area of figure A and the area of B. All right. So we're going to do the 42 minus 30. Right, and get 10 square feet. So we can write it that way. We can also write it 10 SQ FT. We can also write it 10 feet with the superscripted number 2 there. Okay, these are all the same answer. Okay, so, and then it says, so this is the first question. And instead of it saying show your work, it says explain how you found the answer. Explain it. Okay? So you took the area of the first thing, you computed it, you took the area of the second thing, you computed that, and you subtracted them. That's the answer. That's what they want you to write. Okay? And then you're going to give the actual arithmetic showing the expression and the computation with the answer. Okay? So this was about area. Okay, and by the way, we could have counted these 1, 2, 3, 4, 5. Okay, but we know this is a 6 by 7. So one thing kids do wrong is they look at this right here, and they say, "Oh, that's a 6 by 6." Okay, obviously you're going to get 36 then, and your answer would have been 6. So this is not a 6 by 6. Actually, write it out or put tick marks and count it. 1, 2, 3, 4, 5, 6. And I like to do it backwards. 1, 2, 3, 4, 5, 6. Same here. 1, 2, 3, 4, 5, 6, 7. Backwards. 1, 2, 3, 4, 5, 6, 7. So this is definitely 7. Do it that slow, because this is why do you want to get this question wrong? Because you didn't know what the dimensions of the stupid thing was. All right. That's just throwing away points. That's just blowing yourself. And you can get confused. You might be marked wrong in if it was a multiple choice question and just never be able to figure out why. And it's because of your process. Your mathematical solution process is busted. You went too fast. You were hasty, or things like that. Take your time. Figure out what the dimensions are. So this involves the multiplication table. It involves equal parts in the sense that figure A involves, that's all in equal parts, okay? And again, this is a 2-part problem, so there's a multi-part problem again. It also deals with groups, okay? And I'll go a little further about this. And remember, if you said that your answer was 10 feet, so I gave 3 choices here, the answer is not 10 feet. Okay? You're like, I thought you just said it was 10. 42 minus 30 is 10. Oh, wait, did I do that wrong anyway? I keep saying 10 is 12. Okay, so it's not 12. It's not 12 feet. It's 12 square feet. All right? All right. Okay, so let's change the color of the pen a little bit here. And let's explore figure B a little further. Let me use green. Okay. So what we could have done was gotten the area of this part right here. So that's a 6 by 3, and that's 18. Okay. Then there's the area here. Let me change the color again. Or let's do this. Wait a second. The area of this here. Oops. And one more second. Okay, so the area of the green was 18. The area of the yellow is 1, 2, 3, 4 by 2, or 2 by 4. That's equal to 8. And the area of this orangey browny thing is a 2 by 2. And that's equal to 4. Okay, so if we were to add those up, 18 plus 8 plus 4, we would also still get to 30. Okay, so that's one way to do it. We could have also done it another way. And let me change the color again. Let me change it to red. We could have blocked it off like this. Okay, got that. Then we could have blocked up this here. Oops. And got this. And then we have this last part. So that would have been 1, 2, 3, 4, 5, 6, 7 by 2. One, 2, 3, 4, 5, 6, 7 by 2. That's 14. So you would have 14. The next one is 1, 2, 3, 4, 5 by 2. That's 10. So we have 24. And the last is 3 by 2, which is 6. So we get 30 again that way. Okay? All right? And what I'm going to do is erase everything on there for a second, because there's still another way to do this. What's going on here? Why did it not erase that? While I'm doing this, you guys can smash the like button. Subscribe to the channel. Be good network internet citizens. Greg's Tutoring Buds. Okay? Okay, so the other way to do this was to get the whole superstructure here. Okay? This was a 6 by 7 as well, so that's 42 altogether. Okay? And what we're going to do is we can take off these parts here. Depending on how we split them up, there's this A, B, and C part here. Okay, we could have done A and B together or B and C together. So we have a 2 by 4, which is 8, so minus 8. And then a 2 by 2, which is minus 4. So we're going to minus 12 from that. And we get 30 again. See what we did? We took the whole super, took it as a 6 by 7, and we removed these parts from it. Okay? Sometimes that's faster, more efficient, and it's even more mathematically proficient and sound that way. It just seems to be the right way to look at it. Sometimes you have to look at things in unique ways to get new insights into concepts, into problem solving, and things like that. So that's another way to do it. Okay. And by the way, depending on which way you did it, when it asks you to explain, the one thing you're going to say, well, I did the 6x7, and that's 40 unique parts. The other part, you're saying you broke this down into composite shapes. Maybe this whole uppercase A here, and this uppercase B here, and this C, and you added together the composite shapes. Okay. In the case where the last way, which is that you say, I also got a 6x7, and I removed the composite shapes out of it to get the infrastructure of what it was. Okay. So there's things like that. Either way, this is about multiplication tables. It's about realizing how to visually analyze something and either add or remove things. And both ways can work, right? Stuff like that. So that was about the issue with groups. Okay, we have another thing here. We have something that looks like it's in equal parts, and it's split into 1, 2, 3, 4, 5, 6. So these are probably each a sixth if it tells us they're equal. It looks like a rectangle, whereas in the other example a couple ago, I think it was the one with the sandwich. Where did that one end up? Anyway, the other one looked like squares. Each of these six, they look like rectangles to me. Okay, clearly so. But again, it has to tell us. We have to figure that out. So let's go to the words. Jeannie cuts a ribbon, so this whole thing here is a ribbon, into equal pieces as shown. So it is 1/6 size each one, right? So that's a sixth. 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 And the last one's a sixth. She uses 4 pieces of the ribbon for a project. Okay, 4 pieces of the ribbon. There's only one ribbon here. She cuts a ribbon. Which one? There's one right here. She uses 4 pieces of that ribbon. That ribbon. Which one? The same one right here. This is not talking about 4 ribbons. It is not talking about 4 ribbons. It is talking about 4 pieces of that one ribbon. Okay, what fraction of the ribbon does she use for the project? Well, it's part out of whole. Right? If I have a whole out of a whole, then I have the whole thing, right? If I'm trying to get a fraction out of it, it's the part out of the whole. So in our case, how many parts? She took 4 pieces out of the whole ribbon, which was in 6 parts. And that's the answer. 4/6. And this is our mathematical / words for it. Part out of a whole. If you want, you could have added that 4/6 was equal to 2/3. Okay, if you wanted to, you could have shaded in stuff here. Right, those are the four parts out of the 6. Okay, and using the analogy from the previous example, you could have showed that if the whole thing is 6/6 and you didn't use the last 2 pieces, if we subtract 2/6 from 6/6, we also get 4/6. So this doesn't even have to be a geometry question. We can still use this inverse solution mechanism, if you will, even if just for a double check. But this could have been the way you solved it. You could have observed it in that manner, and it's just as valid as observing it in the other manner. Although saying you have 4/6 straight up is normally the way we describe it. Okay, that's our status quo kind of approach to it, if you will. Let's see, what can we say about this? And you could have also done a 6th plus a 6th plus the 6th plus the 6th, and said that was 4/6, that's valid as well. And in each case, whether you convert it back to the 2/3 is up to you. But they're really looking that you got to the 4/6. They're not as concerned at this level that you can do fraction simplification. They're more concerned that you know the part of the whole and actually did it correctly, right? So the answer is not 6/4. That's a no-go. Can no do that either. And the answer is when you get the 4 pieces, some kids are also going to say the answer is 1/4. That's also no-go. You split it into 6 pieces. You're using 4 out of 6. They're equal pieces. 4 out of 6. You have to keep track of that. There's a pattern here going on through all these questions of all this whole series we've done so far. They're really the same questions that students keep getting wrong and wrong and wrong and wrong and wrong and wrong and wrong. Okay, so this is about part of a whole. This is about fractions. It's about minor operations that you're getting 4/6. You know it's a division as well, if you want to look at it that way. 6 going into 4 parts is going to give you that. A student may have converted this to decimal. I'm not even going to go there, but if you want, that's 0.6 bar. That's also a valid answer. If you don't understand what I just wrote, that's cool. It's way beyond the scope of grade 3 math, at least in terms of the curriculum. It's something you may want to do as a sidebar. If anybody wants to explore this, you can please email me if you want. Or if you want me to be your tutor, hint, hint, hint. That's certainly something cool that can happen. My email's at the bottom, GregsTutoringNYC@gmail.com. Okay? So this is part of it a whole, and in particular, equal parts. Okay? If they were unequal, if this was split up into the 6 pieces again, okay, and it was 1, 2, 3, 1, 2, 3, 4, 1, 2, 3. So if this is part 1, part 2, part 3, part 4, part 5, and this whole thing here is part 6. There's no longer, if it says that was the ribbon and she used 4 pieces out of it, which 4 pieces did she use? This, 2, 3, 4, and then it asks us what fraction. We can't solve that unless it tells us the exact length of each piece she took, and then we can distribute the lengths appropriately compared to each other as ratios and so on. But in this case, we are told they were equal pieces. Equal pieces. Okay? Where we keep running into the same thing. And by the way, just to show that the answer could have also been 4 out of 6. And theoretically, it could also have been written as a ratio. Okay? But it does say fraction, so they're really looking for the 4 out of 6 or the 2 out of 3. Okay? Even though these are alternate ways to express that fraction. Okay? Same for this here. They said what fraction. So if you wrote this 0.6 with a bar over it, you didn't answer what they're asking you properly. And again, you must explain. You must offer the explanation in words. And remember, if the thing is, what is 1 plus 1? Your explanation is not 1 plus 1 equals 2. That's just regurgitating the math expression. Okay? You want to include that you understand that's what's happening. But you want to say, you have a whole, and you add to that whole another thing, and now I have 2 things, right? That's the words. You're not just saying 1 plus 1 is 1. 1 plus 1 is 2 just because 1 plus 1 is 2. That's the self-fulfilling kind of definition. So that's a no-go. Okay, so this one is, I believe, the last question we're going to do. Let me see here. Yep. And it's in multiple parts. By the way, even though I'm not focusing on this as test questions, this would be a 3-part question. I think all the ones before this are normally 2-point questions. So depending on how they distribute it, which one they thought was harder, this might have been worth 1 point, and the second question here might be worth 2, or they may do 1.5 each, and so on. And often what happens with a question like this is there's a carry-through. So if you got this wrong, you're probably also going to get this wrong. So there's kind of a dilemma that kind of happens there. Okay, so let me get rid of some of my scribbling there. And let's go for it. Ms. Ross is making breakfast for her family. She should come here. I'm hungry. She makes 15 small pancakes to share equally among 3 people. This is coded language. She has 15 pancakes. Okay, we don't know yet whether they're being small matters to share equally among 3 people. Okay, she's sharing them, so there's a division problem there. So we can get 5 pancakes per person. P over P I'm writing. She's going to get 5 pancakes per person. Okay? How many small pancakes? So they kept the units the same. It's a small pancake here, it's a small pancake there. Will each person get? Okay? So the answer is 5. Okay? It's interesting because they left out the word small. So I think some kids could kind of get upset and say, "Oh, the word small has to be there." That's not really where they're grasping for here. But technically, that would be the unit. It's not just pancakes; it's small pancakes. But since everything involved in the question so far involves that, then we're done. And by the way, we can double check 3 times 5 is equal to 15, right? And by the way, this deals with the very first question we did. This is still a fact family question, where if we're looking at multiplication, if we had 15 and we have 3, what is this here? We're dealing with multiplication. Obviously, it's 5. Okay? Okay? Right? Yeah? Let's see. We can also count up. So if we did, or count down even. 15, 12, 9, 6, 3, right? And the next thing would be left with 0. So we'd have 1, 2, 3, 4, 5 people. We could have done it that way. You could also count up that, 3, 6, 9, 12, 15. That kind of works, although it's slightly backwardish to do it that way. We could have done it graphically. There's 15 pancakes among 3 people. So we could have established 3 pools, if you will, and started giving out the pancake. You get 1, you get 1, you get 1. This is Oprah. 2 each. So we're up to 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay? So we notice this person gets 5, this person got 5, and this person got 5. Again, the easy peasy way is to know your multiplication table. Okay? This was about equal parts again, but involving division. All the other problems, I think, dealt with multiplication. So this is about knowing your operations. Okay? The numbers are not too complicated here. Right? Okay? So we have that. Now we can do the second part, which is here. Miss Ross wants to give each person a glass of orange juice. Okay? There are still 3 people. It's still continuing the same problem. So there's 3 people. Each person gets 8 ounces. How many total ounces of orange juice does she need for everybody? For everybody, that's 24. Okay? Some kids say 8 because it's 8 per person. No, it's asking what's the total for everybody, not just for a person. Okay? If this is not just a reading comprehension question, this is math on top of it. So that's what we're doing with kind of stuff like that. Okay? Some kids are also going to take the answer of this 5 here and do 5 times 8 equals 40. Okay? Because sometimes we use the interim values to feed into the next part. That is not the case on this question. Okay? Part B has nothing to do with Part A except the fact that there's still 3 people. Okay? And you could have wrote this here, by the way, as 8 times 3. That's still cool. Okay? And it says show your work. Okay? If you want to offer words, that can also be showing some of your work. Okay, if you want to do that. So this is about using your multiplication table on both sides of this. It's about knowing your operations. The first one is the division. The second one is the multiplication. It's about using the correct things. It's about using units, okay, because we had to shoot for pancakes again, as always. We're always concerned that that's what we're dealing. Although looking at this alone is often insufficient, it's not always helpful to us completely. And remember, it's saying show your work, so show it. Show it. And you can label stuff. You can say this is ounces, this is number of people, number of peeps. Okay, because remember, this is not multiple choice. In the case that we're now putting on our test-taking hats, which I tend to traditionally avoid with this. Okay, it's not there. Okay, and by the way, the same way you weren't supposed to take this 5 and the answer wasn't 8, the answer is not 3 either. 3 was the number of people. So don't get whacked out here, guys. All right. What else could we do here? You know, we could have done 8 plus 8 plus 8 equals 24. Right? 8 for each person. One person got 8. Second person got 8. Third person got 8. You get to 24 ounces that way. And technically, you should be putting your units down so that the person grading it knows what you're doing, and just to get your brain in the right think state, in the right perspective, because that's what the questions ask you. How many total ounces? So you want to make sure that you match those units. Not just to get a point for putting them down, but to make sure you know that you're trying to solve the correct question, the correct problem, that your solution is on board. I talked about in some of the other sessions about estimating and feeding your answers back into questions. Well, if you're dealing with number of people, you're in the left field, bro. You're not going to be solving your question properly, and things like that. All right, so that is the last thing there, and please subscribe to the channel, and let's do some more hard math problems. Yeah. So the next time I'm going to skip into grade 4. Booyah! All right, guys, take it easy. Bye.